So what we would have covered on Wednesday, we're covering today. So today we're finishing up linear applications and models. And we're also looking at systems of linear equations, because this gives us the ability to solve some of these problems using 2 variables instead of 1. Remember, on Monday, we were only able to solve some of those application problems in terms of 1 variable. So I will be distributing the take-home quiz at the end of class, and that's due on Monday. And then note that Monday and Wednesday next week will be the last material we cover for the first test. But both of these classes are packed with material. So make sure, if at all possible, you don't miss classes on Monday or Wednesday next week. Okay? So let's see. And that puts our first test off. It would have been next Friday, but Monday after Friday's President's Day. So it's actually not going to be until February 22nd now. No, Monday the 20th, there are no classes, day classes that day. This Monday is the 13th, and and this is our class. Oh, okay. Well, at some point, if we keep missing snow days, what's going to have to come off these review days are kind of like, I don't want to call them bonus days, but they're sort of put in there. I never used to give review before tests. I would just start the next material, and then you'd have like 4 days in between. So at some point, if we keep having snow days, we're going to have to start chopping off some of these review days. And chances are I would take away the first review day, because as the material goes on, it gets more intense, and I'd rather save these review days if at all possible. So let's hope Monday we don't lose another day, but we can't control the weather. And also at some point I might say, if we miss a day, first of all, that reminds me, please read your GCC email, because it's my only way of communicating with you. So like if for some reason Monday's class isn't going to happen, I might say, watch the video that I have on YouTube, and I'll just take a video from the fall and put it in, because it's the same type of class notes and everything. And that's always true. If you're looking for a video from this semester and I haven't put it up yet, you can go to the fall, you could go to last spring and look for the same video. I make changes in the class notes, but for the most part, the material and the class activities are the same. But I think for this week or so, I would get rid of the review for the test if we have another snow day. So let's take a look at the preview activities. I'd like to go through these together, because I want you to have enough time to work on the class activities, and also to finish up class activities from Monday, which I wrote you a little email from. I'm just curious, how many people paid no attention to any of the GCC email? So I had sent out a couple of messages. Or you don't want to identify yourself? How many people paid attention? No. All right. So the point is, it's my only way I can get you information. So please take a peek at, especially on snow days, to your GCC email. Okay. All right. So let's take a look at these statements here. So the first statement asks if the ordered pair 4, -1 satisfies this equation. What do I mean by the language satisfies? What does that mean? Yeah. It's true. What's going to be true, James?
Both sides of the equation.
When what happens?
When x equals 4 for y.
Right. So when I substitute x equals 4 in for x, and I substitute -1 in for y, then the left side and the right side should equal each other. And we do. We get 2 = 2. So to say that the ordered pair 4, -1 satisfies this equation means it's a solution for that equation. It's another way to say it's a solution. It satisfies the equation. The left side equals the right side. And this equation is a linear equation in two variables, right? We could actually graph this. So let's do that now. So when you see an equation like x plus 2y equals 2, one of your first instincts is to make changes to this equation and make it into the form y equals some number times x, mx plus b. That's not necessary, and it also could introduce some errors. When you see an equation in this form where your constant term, 2, is on the right, and both your variable terms are on the left-hand side, don't mess with it, because your intercept method for graphing comes in very handy here. If you let x equals 0 and you find your y-intercept, look at how quickly you can solve. I'm going to cover up the x with my hand because x is 0. What's y going to be to make the left side equal the right side? 1. So you got a point right away, 0, 1. You're done with that. You only need 2 points to graph a line. Notice I have rulers on your table, by the way, or if you have your studio bookmark, these are really good as well. So that's the y-intercept. And now let's find the x-intercept. The x-intercept is when y is 0. So when y is 0, I cover up 2y. What's x got to be? 2. Look how quick that is. Right? No need to manipulate the equations to make it look like y equals mx plus b. It's just one form of a line. So then you're just going to connect those 2 points, the straight line, and you should label it. Always label whatever the equation for whatever line you're graphing. It's good practice. So there we go. Every single point on that line satisfies this equation or represents the solution set. This line represents the solution set for that equation. X plus 2y is 2. All right, so let's take a look at the next question. So A is true. And now it says, does 4, -1 satisfy x take away 2y equals 6? For those of you, I know there's always someone that goes ahead. Does that satisfy that equation? I hear a no, and I hear a yes. It does, and I hear a no. So it looks like we have some controversy, so let's give it a try. X is 4, take away 2 times a -1. That's 4 plus 2, and that equals 6. So it is a solution to that equation as well. So today, when we talk about linear systems, equations, linear equations taken together, looked at the same time, and one way to think of that is we could plot them and see what the solution is, the common solution, if there is one. But when we say that 4, -1 is a solution to the system, what it means is that 4, -1 is a solution for this equation and is a solution for that equation. In other words, 4, -1 is a point on both of those lines, so it's a common solution. So let's take a look at graphing that second line. Let's do that in green. X take away 2y equals 6. When x is 0, y is -3. That's the y-intercept. And when y is 0, x is 6. That's the x-intercept. And when I connect these with a line, let's see if I can do it here. Here we go. We'll label it x minus 2y is 6. Notice that solution is 4, -1. That's where they intersect. So when two lines intersect, that common point, that intersection point, is a common solution. It's a common solution for both lines or to the system, the linear system. So for those of you who are in business, this is often referred to as the break-even point. And we'll be studying that a little bit today in the class activities. So for those of you not in business, let me just give you a real quick, uh, synopsis of cost and revenue. So if I said that I was starting a coffee business and it took me $20,000, you don't have to write this down. I invested $20,000 to start the business. And let's say I was just selling pounds of coffee, and I'm just making this up, and all my coffee was $8 per pound. All right. Well, the cost, let's say it cost $8 for every pound of coffee I produced, and I sold it for $15. This is my selling price. Well, I'd be concerned with two things. At some point, I'm hoping that the revenue I take in my business outpace or is more than my costs for both producing the coffee and that initial fixed cost for starting my business. And then I would make what we call a profit. I would have a gain. So the two things I need to consider is what's the cost and what's my revenue. Okay. So the cost, if I let X be the number of pounds of coffee I produce and sell, then my cost would be my initial cost plus the cost for producing each pound of coffee. At the same time, I would be bringing in $15 per pound times the same number of pounds that I'm selling, and that would be my revenue. And if you wanted to, you could differentiate between those two Y's with a little subscript like that, cost and revenue. And so this is a system. It's two equations, two linear equations. And if you were to graph these, this one would start way up high at 20,000, because when X is 0, that's 20,000. My revenue at 0 is 0. And at some point, those two lines will intersect. That point is the solution common to both of these. That point, the X value for that point, is the number of pounds you would be producing and selling that would make your cost and revenue equal. And when your cost and revenue are equal, you've lost no money, you've gained no money. So everything prior to here is a loss, because you can see your cost. Let's make our cost red. The costs before this point are still higher at every single value of X than your revenue. And then after that point, your revenue is higher than your cost, so that's where you're making a gain. So today, you're going to be working with this concept for two of your class activities. But I realized today that some people were not familiar with this idea of revenue and cost. So when you want to find that point, this is what you do. You set those two equations equal to each other. When are these two equations equal? And you solve for X, and then you get your Y as well. Okay. So let's take a quick look here at a system of linear equations. I'm actually going to skip this. This picture is pretty straightforward. It's right out of your book. You can read this in your book. It's just a graph of the percentage of people in the US who have never married and married X number of years out from 1970. It's done in decades. And I'm asking you to estimate this point. That would be the point where your percentage of married and never married were the same, are equal, okay? So let's take a look at how to actually find that point, because these are the methods that you'll be using today. And here's our system. And when you want to solve a system, you're looking for an ordered pair that's a solution to both of those equations. There's two methods, and I'm sure these methods are pretty much a review for you. So let's take a look at them. One is called the substitution method, and it involves looking at your system and saying, can I easily rewrite one of my variables in terms of the other. And what I mean by that is one of your variables does it already have a 1 as a coefficient? And you can see in this very first equation right here that x has a 1 for a coefficient. So you could take that equation and easily rewrite x in terms of y by solving for x. You would get x equals 142 take away 2y. X equals 142 take away 2y. So now your system looks like this. You've taken that first equation and you've written it as an equivalent equation like that. And your second equation hasn't changed at all. But now you have the ability to rewrite the second equation by taking x, which is now defined as 142 take away 2y, and substituting that in where you see x in your second equation. So you substitute for x. And I'm going to keep that blue so you can see how it works. So I rewrite my second equation, -3, and instead of calling it x, I call it 142 minus 2y. I just substitute an equivalent statement for it. Plus 10y equals 160. Now, instead of having two equations with two unknowns, you have one equation. So here you've met your goal here. You have one equation with one unknown variable, and now you can solve for y. Before this, you couldn't have done it. You can't solve one equation with two unknowns, but we certainly know how to solve one equation with one unknown. So we use our distributive property here, and we get -426 plus 6y plus 10y equals 160. We combine like terms and we get -426 plus 16y equals 160. And then we add 426 to both sides and we get 16y equals 685. And then we divide both sides by 16. And my handy dandy calculator says, let's see what it says here, 586 divided by 16 gives me 36.625. So y is 36.625. Nope, no rounding. That's it exactly. 0.625 is a fraction 5/8. 62.5% is 0.625. Okay, am I done? Have I found the solution to that system? Yeah, I got to do x, right? So, because remember the solution to a system, a linear system, is an ordered pair. So I need both my x and y. So now you go back, never go back to any equation you've manipulated from the original. Always go back to one of your original equations. So I'm going to pick on my first equation here and say x plus 2 times y, 36.625 equals 142. Okay, so that means x is going to be 142 take away 2 times 36.625. 68.75. So that's the method of elimination, of addition. The method of addition. That's right. So where these two lines intersected back here, Jesse, that point exactly, we could only estimate it if we were just looking at the graph, but now we've done the algebra, and the algebra tells us that that point has these coordinates. So basically, 68 3/4 years after 1970, 36.625% of the population will be both married and never married. Not both, but 36.625% of the population will be married, and 36.625% of the population will be never married. And the rest falls in some other category like divorced or widowed or I don't know what. Okay. Those are just two I can think of off the top of my head. All right. So that's one of the methods. And you want to use this method if you look at your variables and you see a 1, because it's pretty straight, it's pretty quick and easy. The other method has two different names. Addition, which is the process you go through in the method. The elimination method is the goal of the method. So if we look at this system, we know one of our goals is to come up with an equation with one variable. So since we have two variables, we have to eliminate one of them. That's the goal. And the way we do that is by adding both equations together. So if I added both of these equations together right now, don't write this down, you don't have to write this down, I'd get negative 2x plus 12y equals 302, which doesn't help me at all, okay? Because now I have one equation with two unknowns, so that's not going to do any good. And I'm allowed to add these together because the left sides are equal to the right sides. So let's see. If my goal is to get rid of one of these variables, and I'm going to add everything on the left side, straight down like this, and everything on the right side, then one way that I could eliminate one of those variables is to have the terms, when I add them together, come out to be 0 times x or 0 times y. Then one of them will just be eliminated. So it's much easier, I think, for me to just multiply. If I look at this first column here, 1x take away 3x, since they already have different signs, 1 is positive and negative 3 is negative, then I could just multiply this first equation by 3 all the way across. So if I do that, I'm going to get 3 times x plus 3 times 2x, excuse me, 2y equals 3 times 142, right? So I've just multiplied everything in that first equation by 3, which I have the right to do because I can multiply both sides of an equation by a non-zero number anytime I feel like it without changing it. And now look what happens when I add everything on the left side and everything on the right side. So I get 3x, take away 3x gives me 0x. Yoo-hoo! That's gone. It's eliminated because that's just a 0. And I get 3 times 2, 6y plus 10y is 16y. And on this side, I get 586. Lo and behold, that's exactly what we had up here. Right here, look, 16y equals 586 when we were using the other method. So our answer comes out to be exactly the same, 68.75 and 36.625. So there are times you have to look at each system and determine which method you want to use. Sometimes one is easier than the other. Sometimes people say, I always use the addition method no matter what, because that's the one I know the best. Does it matter, Linda, which one I use? And I say, absolutely not, whatever you want to use. Jesse? If it was flipped, what do you mean?
So if it was negative 3x,
I would still multiply by 3. Yep. 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 So if we want to make up another one, if I had x minus 10y equals some number over here, and I had negative 6x minus 20y equaled another number here, and I was trying to consider which one to get rid of, I would always pick the one that had a positive and a negative. And so I would choose to multiply this top one by what, Jesse? What would you multiply? By 6, all the way across, right? Perfect. Okay. All right, so you have time now to work on your, oop, I have to do this one, I forgot. All right, so Monday, we had a problem very similar to this. In fact, let's go back and see what it looked like on Monday. Let's see. What did you do? Oh, that was a Monday, was it? Here it is. Yeah. Okay. So here was Monday's class. We talked about this. Okay, so here's where we were talking about taking $3,000 and separating it into 2 accounts. And remember, we called the amount in one account X, and because we only could use one variable, we had to call the other amount 3,000 minus X. Well, now we're going to have the ability to call one amount X and one amount Y, which makes life a lot easier for us. So I want to read this problem because my voice is running out. Nora, want to read that for us?
A scholarship fund has $10,000. Invest in 2 funds, one low risk and one high.
Actually, today 4% would be considered high, right? We'd be doing pretty good if we could keep it at 4%. Okay, so again, look at the question. How much should we invest in each fund? Boom! Your first 2 variables and their description is given to you right there. Now, I'm going to do this table in a minute. But for those of you who don't do the table and you want full credit for your Word applications on tests and quizzes and all that, you have to define for me and whoever's reading your work what your variable expressions represent. So you'll see this in a minute in the table, but if you don't have this table, then you have to say X, and if you use a Y, you have to tell me what the heck they are. So X would be, say, the amount in dollars invested in the 4% account. But does that take too long to write? No. And it doesn't take me too long to write -1 and -2 either, which I prefer not to do because I love giving everybody as much credit as possible. Okay, so this is helpful, not some, just to understand what you're doing when you're creating these equations, what they are actually saying to you in variables without the written language, because you've described it right here. So in your head, you've got a connection made. So what would I write for Y? Right, and at this point, I can go ditto, ditto, and just put 8%. See, I can even be lazy. It's okay. All right, I've got 2 more variable expressions to represent. This deals with the amount of money. What else am I dealing with in this problem? Well, what's the return called? The amount of interest. So 0.04 times X is a variable expression. It means something. It doesn't mean 4%. 4% has no units on it. A percentage has no units. You don't know what, it has no meaning in terms of a context. The X has a context. It's dollars. So you're taking apart a small piece of that amount of money, and we're calling that interest. That expression represents the amount of interest in dollars earned on X dollars. That's the amount of interest you earn on X dollars. You don't have to say it's in the 4% account because the coefficient tells you that, the 0.04, so it's redundant. The 0.08y expression, dot, 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 the amount of interest earned on y dollars. You can write that, then you can come up with the two what equals what's, the two equations, because you've already literally formed the relationship in your head. You know X and Y are the two amounts of money, and when you look up here, it said you had $10,000 to invest. So what relationship do you know about X and Y? Yep. Right. You know X plus Y has to be 10,000 because X and Y represent the $2 amounts that you've invested. And these two expressions, 0.04x and 0.08y, represent the two amounts of interest you earned after 1 year. What can you tell me about those two amounts? Other than Cyrus. Paul, can you tell me anything about those two amounts? I think you can. Because what can you tell me about these two amounts of interest? Is there anything telling me about those two amounts of interest in the problem? Does it tell you how much interest you got that year? $550. So that means if you took this amount of interest and added it to that amount of interest, you would get $550, right? Are you just saying that? No. All right. So this amount of interest, that's the amount of interest earned in that first account on the X dollars you invested, plus this amount of interest earned on the Y dollars, came out to be after 1 year, 550. So here's your linear system with two variables. And now you can use whatever method you want to solve it. Okay, let's not do that right yet. I want to come back to this table now. All of this language, folks, all of this language is included in this table, including the proper language. Notice amount invested with units, dollars. So if you write that as a heading, you get a check and a check for these first two variable expressions. Amount of interest with dollars is the definition of these two variable expressions. So the lower rate and the higher rate is what you're looking at in this problem. You're investing money at two different rates. So if you do an X and a Y here, and then look, you're usually told a total. You're usually told a total. Sometimes you might be told a relationship, like you might say you put 500 more in one account than the other. So you don't come up with a total here. It's usually a total or some relationship between those two. So look, you add those two up, 10,000. Look at that. You've got your first equation. Boom. There it is. X plus Y is 10,000. The middle, you put each of your percentages as a decimal, being careful not to make a mistake. And when you multiply across each row, you get the amount of interest that you've earned on each of those accounts. And then again, you're either told the total interest or a relationship between the amounts of interest. In this case, you're told the total, and there is your second equation. And from here, you solve the equation by using either substitution or elimination. So I'm just curious, how many people would solve this system using elimination or addition by making it so that you get rid of one of the variables? 2, elimination, 3, and the rest of you would do substitution? Look what happens when you take that first equation and you solve it for y. It should look just like what you did on Monday. That looked just like what you did on Monday when you only had one variable to use. You call the first one x, and the second one was your total minus x. So it all kind of comes around. Now you take that 10,000 minus x and you put it in for y, and you solve that second equation for X. So let's do that. And then you'll be all set to work on your activities. So 0.04x plus 800 minus 0.08x equals 550. Negative 0.04x plus 800 equals 550. I'll scoot up here. Negative 0.04x equals negative 250. X equals $62.50. If I divide both sides by negative 0.04. Nobody's gotten that far? All right, let's try it. This thing is just so big these days. Whoa. So let's turn it on. Clear it out. 550 divided by 0.04. Notice I didn't include the signs because negative divided by negative is the same as positive divided by positive. And what do I get? Oh, it's not supposed to, it's supposed to be 250. 250 divided by 0.04. 6250. So X is 6250. Y then would be 3750. So when you write your sentence, that's when you include your units. You would say, I invested $6,250 in the 4% account and the remainder $37.50 dollars in the 8% account. Okay. So you have quite a few problems to practice today, and I'm sure you'll find something that holds your interest. They have varying degrees of difficulty, so you could look them all over. If you wanted to do one just like this, you could immediately, instead of starting with number 1, you could go right up to either number 4 or number 5. No, not number 4 would be the one where you could do your table with. A break-even problem, you have 1 and 2. Number 1 takes you step by step, and then number 2 sort of doesn't take you step by step anymore, but is now asking you to perform those steps on your own. Please let me know if you have any questions. I'll be glad to help you.